So today we're going to talk about Chef in the Chef way. So I'm Ryan Moon. I work at a company called Slack. Probably the t-shirt told you that. I currently am the senior client platform engineer. The client platform engineering team is right here, so we have to take separate planes. A couple things about me. I really want to BMX. If anyone wants to talk BMX bikes, I'm interested. I'm on Twitter. I don't really use it except to talk about sandwiches, because sandwiches are great. I'm on the Mac admin Slack. I'm also on the Chef community Slack. That is a Reactie and used in Slack because apparently I say no a lot. So the Reactie is that's no Moon, and that's me.
I'm Lucas. I'm a client platform engineer at Slack. I'm new here, relatively. I've been there about 6 months. I started at Slack at the end of January. I'm on Twitter. I mostly just lurk, and then I'm also at Lucas, lowercase l, in the Chef Slack and the Mac admin Slack. Yeah. So, where we are. I'm actually based out of Denver, and then Moon here is based out of SFO. So, we're client platform engineering. We're responsible for the Mac OS, Windows, Linux, and then some cloud-based infrastructure that kind of all falls under our Chef base. We have a little bit more than 10 machines or so under our, that was a joke. It's a poor joke. We're here to talk the Chef curve is something that we'll kind of allude to throughout this, and then we want to kind of talk about another voice in the Mac admins community as far as it's concerned to client platform engineering when it comes to Chef as a config management software. And then how we got here. Really, this was mostly Ryan. He had a lot of everything, pretty much everything that we're going to talk about today laid down before I arrived. And I kind of came into this infrastructure methodology with a relatively clean slate. I had only had a few other, Kool-Aid experiences with other Chef methodologies that he cleared me of really quick. So, yeah.
Yeah, I'm the raccoon in this scenario.
Yeah, so really it's based around a desire for all of the code within the Chef infrastructure to be tested. Everything's version controlled. Within the code structure, everything can be kind of selectively deployed, which we'll refer to as version pinning later. And then all of it coming together in a way that's documented and accessible in a way that you don't need to know anything specific about how we do Chef to know how to use Chef the way we use it, if that makes sense. Cool. So yeah, we're going to talk about what is Chef. The main purpose of this talk is to really examine Chef at a high level, taking a step back and looking at the entire ecosystem. There's been many talks about Chef at Mac admins and other conferences throughout the years, usually delving into runtimes and things like that. We're not really going to get that far into the weeds about particularly how Chef runs item potency and things like that. This is more to just kind of give you an idea of what Chef is and like how you see it in the ecosystem and why that could be beneficial for you, or why it's very overwhelming and you don't want to touch it. So yeah, that's kind of the TLDR of why we're here. So really, at times, it's probably going to feel like drinking from a fire hose because Chef in and of itself is so inherently complex in this methodology that yeah, it's going to be a lot. So
when we talk about the Chef ecosystem, Chef has a really great slide that's really easy to understand. I drew one out and it was much worse, so we just used this one, and it took a couple different iterations. So we're gonna really focus on a lot of the higher level components and why you may want to use them, and also how we use them, that kind of idea like that. And it really just kind of sometimes feels like this. You're talking like this, and one of the hardest things I've ever had to do is explain what I do to someone. They're like, no, what do you really do? I'm like, well, we use this tool called Chef, and then there's this, and there's this, and there's this, and then this, and then, yeah, I'm basically just looking like that. So we're gonna kind of focus on a really kind of a subset of all the things that are in Chef, because really, Chef started off, as you may or may not know, as a really great tool to manage server infrastructure. And that's where it's used for the most part. And then a long time ago, I'm like, hey, this sounds great. I want to have a career. I want to be DevOpsy. I'll use Chef to manage endpoints. And then I went to a couple different Chef things, and people were like, what? Why? Like, we use it to manage Apache, or all the different things like that. So it really kind of, the way that we do it, really kind of mirrors a rough idea of what a lot of companies use for their infrastructure in production. Slack, the actual company that we work for, on the production side, they use Chef. They use it differently than we do, but it's still kind of the same and analogous, that kind of idea like that. So one of the things we're going to talk about at the top level is we have the Chef server. So we use a server to kind of interact with all of our nodes and the clients. And node to client would be pretty much the endpoint or the laptop, that kind of device you're managing there. And the nice thing about the Chef server, the front end's written in Erlang. So I'm sure there's a lot of Erlang fans here. I had to look it up on Wikipedia because I didn't know it, but there's a really great quote. There is one Erlang fan here, so we got that going for us. Yes. If Java is write once anywhere, Erlang is write once, run forever. We can talk about Java and Erlang. Kind of fun as that. I have honestly no idea why I really focus on the Erlang thing, but I don't know, I saw that and I was like, oh, that's pretty neat. Also, that's a lemur. So, one of the things here we got is that this server is going to be storing cookbooks, any of the policies if you're going to apply to a node, metadata, all kinds of different things like that. That's all going in the Chef server. And then there's a whole bunch of different things that you can do based off of the Chef server to gather a lot more information on all the things that are running in your infrastructure. We'll get to that because that's all a talk in itself, but high level, you got the Chef server kind of at the top there, if you want to think of it there. Next up, we have the environments. And this bear is just thinking about the last time he ate at Yoshinoya. He enjoyed that beef bowl. And an environment is really the way to map certain things to your nodes. You can kind of think of this as ways you can do, like cookbooks that are available to nodes. Also things like attributes, which we'll talk about in the next couple of slides here. It's a JSON file, and who doesn't love JSON? So there you got that going for it. So in the environments, one of the things that we do at Slack that's kind of adapted from kind of a community standard here is we do a different environment for different kind of, business functions. So endpoints are the vast majority of the fleet which we manage at Slack. But we have different things like Zoom rooms, Zoom displays, all different things like that, and you're going to be applying different settings to them. And the nice thing with Chef that we can do is we can have a cookbook that does, hey, this is just going to put monkey on a machine. And then we can say, if it's in the endpoint environment, it gets a couple different settings. If it's in the Zoom environment, it gets a couple different settings and different things like that. So an example of this is you can kind of think of these as kind of all the base level cookbooks that we're applying at an environment. And let's say this is just all in the dev environment. And then we're moving up, and then we're talking about the production environment. And you can do specific cookbook version pinning within this. So you can say, hey, this if you're in production, you get monkey version 4.0. If you're in the dev environment, you just get whatever we happen to throw on your machine. So don't be in the dev environment. And then if we want to do something extra special, we can then do an additional version pin on top of that and talk about things for like CI, CD. Maybe we want a specific version that runs on different things like that. So we have a lot of control and flexibility when we talk about using kind of the environments at this top level. Next up, we have roles. That's an otter. And we don't use roles very much. We use them pretty simple. It's just like, it's got one thing in there. You can really use roles to do a bunch of complex things. It's generally been considered to be more of something what someone would call an anti-pattern by the greater like Chef server community. But if you didn't have a lot of logic and we're just kind of starting out, you can say like, hey, this is a role, this is for my endpoints, this is for like, I don't know, my IMAX or different things like that. You could have a specific role and tether that to devices. Or you can get further on, you can use additional logic and different aspects. One of the things that we put in a role is a run list of what cookbooks are going to be run against a node. We're talking about Cookbook. So a cookbook is where we're going to like store all of the information, such as the recipes, the resources, attributes. And again, I'm talking from the top level down, so I'm mentioning something that I'm going to be talking about in the future. So I'm kind of in the past talking to my future self. It's a little odd. One thing about Chef is that it's like a really bad dad joke that just refuses to give the bit up, but then fails in certain regards. So you have the cookbook and you have recipes, and then you have something called resources. It's like, well, it fell apart there. Like if you would have named it fixins or spices, different things like that. I was really kind of hoping for that. It also, for a long time, doing any Google searches for these things were horrible. So you had to kind of qualify it by throwing like ops code in there and different things like that. Thankfully, that's gotten a lot better. But really, a cookbook's going to define a scenario and then really have all the components required to support that scenario that you're trying to do. And our recipes here. And a recipe is within a cookbook. It's going to be used to define really kind of an action. It's really the doer here. It can reference other recipes. We're going to show a series of examples. That's actually what Lucas is going to do. That really kind of tie all these things together. That's really great. I'm just showing you pictures of animals and giving you vague descriptions of things. Here we go. This is one of my favorite pictures ever. It shows up later, just foreshadowing. I think it's his name. We'll call him Paul. I kind of like Paul. So a resource is a Ruby block. And Nate gave a talk yesterday, and he was talking about using different kinds of resources. And it's a Ruby block with 4 components: the type, a name, 1 or more properties with values associated with it, and 1 or more actions. And you can kind of think of them as functions. So I spent most of I still really like writing things in Bash. I don't know what that makes me, probably a monster, but I know it and it's really great. And once I found out about functions in Bash, I was like, oh, this is the most amazing thing ever. Now my 17,000 line shell script can only be 13,000 lines. So Chef itself has about 129 built-in resources. These are all just built in as part of the community builds. These are things that the community has added to Chef as whole, as well as just have been a part of things always. My favorite resource for the longest time has been template. One of the reasons it is my favorite resource is one of my first practical uses of Chef was putting a script on Open Directory servers to have a programmatic way to create users. It started off as a 8,000 line script because I had to account for every single scenario. And then I found out about Chef and templates and how you can do templates, and it's an ERB file. So you can basically, I only had about like 6 different lines that changed based on the environment. And then I used environments and templates, and now I had a shorter, nicer Bash script. A lot of this is really just my secret way to make Bash scripts better on endpoints. So I use Chef for a lot. You can join several of them together to create a custom resource. We're going to talk a little bit later about a resource that we use that does a remote package. It pulls it from S3, it installs the package, all the different things like that. And that's just a combination of about 6 or 7 different base resources all compiled into one that you can reuse at a later point. I think one of the things that when people talk about Chef is they immediately talk about, hey, you can build your own custom resources. You don't really have to. You can just use the built-in resources to accomplish that. And then once you start doing something enough times and you get annoyed with it, you could kind of build it into a custom resource if it's going to be something you're going to reuse over and over again. Next up, we have Ojai. And Ojai is one of the nicest things about Chef is this is just part of every Chef run. And this is information about the node. One of the nice things about Chef and that I find is really super powerful is you can use a lot of data to define your logic and how you're going to do things. Ojai has some built-in ones that are really nice and great, but you can also write your own Ojai plugins, like how that bear is awesome. And Ojai you can also think of as a subset of as an attribute. And an attribute you can really kind of think of as variables within different recipes and different items like that. One of the things that I think is a little bit confusing when you come into Chef is the concept of the namespace, where it's, you know, something like maybe the name of the cookbook and then another thing there is like, where did that come from? That's just picked from a sense that makes logistic sense to you. So you could have a namespace that was all about your favorite types of sandwiches. So, you know, it could be pastrami pickles, pastrami's with spicy mustard, those different things like that. It doesn't matter. It's just like naming a variable. You could name it A or B or something like that. When we talk about attributes, we have a whole series of nice things. Everyone should memorize this chart. We'll be asking questions about it later. But it's the levels by which you can kind of think of your precedence order. So if you try and say something's at a default, you can override it at different levels, and it's kind of which is the override that matters the most. Automatic, number 15, which is the topmost precedence, that's Ojai. So if you try and overwrite an Ojai attribute in your cookbook, you're gonna have a bad time. So probably not do that. So let's talk more specifically about endpoints, you know, like computers. Lucas.
Cool. So yeah, so we're going to, I'm going to hop back real quick because I like this. So if you kind of look, all of the things that Moon was talking about are illustrated in some way or another on this. You can see the cookbooks that live on the workstation, the recipes within the cookbooks and tests, and the controls within the tests. And then below that is a subset of icons, Test Kitchen, Inspec, Rubicop or Cook Style, and Food Critic, which we're going to talk about, and that's more about the Chef testing environment that we're going to get in. And then, so within this workstation environment, which is blue, that's all of the local development as far as the cookbooks go. So things that you would be doing like on your machine, writing, linting, testing, and then above that is like Moon saying the Chef server, where you'll then send the cookbooks up, and then from there they get distributed out to the. Oh, sorry, there's nobody in here. I'm just kidding. All right, there we go. I'm not going to start over if that's okay with everybody. And then from there it gets distributed out to the different platforms. So yeah, so we're going to look at an in-practice example. Just kind of went over that. I don't know if you've ever heard of a package management tool called Monkey. I feel like this is the favorite illustration for every talk at this conference. But so, you know, a sample setup of something could be like Monkey is also integrated with Monkey Report, also integrated with maybe a middleware. For sake of this, I'm really, in time and complexity, I'm really just going to focus on Monkey itself, that being Manage Software Update in the GUI. So yeah, so we're actually going to take this from kind of the top of like, let's look at a recipe, let's look at how the recipe interacts with each other, let's look at the resources it calls, let's see how that kind of all fits together with inside of a cookbook. We're going to run some tests against it, and then we're going to lint it against it, run some tests, and then we'll actually do an integration test in not real time, although we probably would have had time. Cool. So this is a default recipe within our example Monkey cookbook. A lot of, you know, if you're somebody who's used Chef or uses Chef, you may be like, why are you doing it this way? And the reason we do this, and this is pretty much true across all of our cookbooks, is we have a default recipe that has logic based off of node type. So you can see in the line, it's basically determining the platform family. And so if the platform's family is macOS, then it's going to run the recipe macOS _ Monkey. So at this point, you could add in multiple lines based on different operating systems or different platforms, if you will, of other recipes that you would want to run based off this. Now, Monkey itself is pretty much only specific to Mac, but if you had, for example, like an SSHD conf or something you wanted to lay down across your Linux machines or multiple things, you could do that right here. So inside the macOS X Monkey recipe, you can see that it includes the recipe for Ojai. So we're going to pull in our specific Slack Ojai plugins that we've written to use that information, and then we're just going to start iterating through the included recipes. So the first recipe that's included is the client configuration, followed by the client install, and those are the two examples that we look at. You can kind of notice down towards the bottom there's some more logic, but yeah, we'll come back to that. So here's a configuration. So we actually have a custom resource that that Moon wrote, I should say, called Slack CPE profile, and basically we kind of wrapped a way that you can generate profiles on the Mac, RIP in the future, but we supply some UIDs, the display name, and then we use a cookbook preferences, and we point that to node CPE monkey preferences, and then if you look inside of that, that's actually where all of the information about the profile lives, and all of the settings that we want to transpose into the profile. So if you look at the left side of the Atom window, you can see we're actually in an attributes file, and this attributes file allows us to define any of these attributes under these namespaces and then call them within the recipes, within the resources, etc. So I think there's another example down towards the bottom. So yeah, so here's the CloudFront middleware is an example too. So you can see access ID and things like that. Again, this is a sample one. You can deal with your secrets and things however you feel like it's necessary. That could also be a profile too, for example. But the idea being just that attributes can be defined separately and then overridden down the line. So if you have an environment where you want a specific set of machines in Monkey, which probably isn't the case, to use a different repo or something, you could override that attribute higher up the line and things like that. This is just setting the defaults of what these profiles will be set as. So then we look at the install recipe, so the next one down. So this is another custom resource like Moon mentioned, that's just going to S3, pulling a package and installing the package, providing the version number, a checksum. It's going to write a receipt, and then also there's two lines in there called not if, and we actually do a SHA-256 sum against the CLI tool for Managed Software Update, and then also against the actual app itself within Managed Software Center. So if any of those don't match, Chef will automatically try to reinstall Monkey tools on the client. And if it does run, you can see down there below, we're not really going to get into this too much, but it notifies on run bash monkey reload. So only when this installs, it'll notify the next section down, which you can see is bash monkey reload, which is just a bash script to reload all of the Monkey tools. If you don't use Monkey, I apologize for this illustration. You can still kind of get the idea of being able to, check for SHA sums, install things, call custom resources, etc. So back to the Monkey base recipe, if you will, you can see all of the different ways that we iterate through the different installs. So client config, so that's like the profile, client install, monkey report config, monkey report install, so on and so forth, down through the different things. Down at the bottom, so we're casing out a node Slack type, so that's coming from our custom OHI. So if our custom OHI determines that a machine is a specific thing, for example, engineering, then include, I don't actually think engineering is an example there, endpoint. So if it cases out that the machine is an endpoint type, then include the recipe extra packages. And that extra packages just writes a local manifest in Monkey, which will then pull down those extra packages for that specific type. Same for, I think the other one's a network check, which is another check that we have in there. So you better check yourself before you wreck yourself. We're going to talk about linting and unit testing. This was something that was, when I first started working with Ryan, like I had an idea of Chef and I had an idea like this, but this is where I feel like for me it was really awesome to see the next level of what this environment can do as far as being able to lint and test and integrate your code. So just some semantics. So Chef is Ruby, so they have a Rakefile, which is very similar to a Makefile, and then Rake, which is the process by which you run that against your checks. So yeah, this is awesome because you can, in a Rakefile, you can specifically write out tasks and prerequisites and logic around the stuff that you want to do. yeah, it's really cool. So we're going to talk about two kind of tools that we'll call from that, which is Rubocop, which is a Ruby linter, and which is just for Ruby syntax, and then Food Critic, which is chef-specific linting against cookbooks. And both of these things have their own websites. You can go check them out. All of that stuff will be at the end. This is all community maintained and presented. So these are all open tools that you can go out and look and customize. We use a specific, correct me if I'm wrong, it's like a specific subset of Rubocop. It's called like Cook Style, and it's like specifically Ruby for chef code. Yeah. So here's a small snippet of a Rakefile, for example. And what we're doing inside of here is we're kind of defining out these different tasks, these different linting tasks that we want to do. So under the namespace lint, we're also going to do a Ruby lint, which we can see we call Rubocop rake task. And then under the next one, you can see there's a chef lint, and from that we call Food Critic for the rake and the lint task. And all of that will present itself in CLI form. So we can say chef exec rake lint Ruby, or chef, or just call the lint file in and of itself, which will then run both tasks in order. So you lint both at the same time, but for sake of illustration, we'll just run a Ruby lint, and this is great. It's a simple check, run it, make sure that your code is formatted in the way that's expected in Ruby. It can check it, and then you can go back and correct it, and then if you run it again, once you correct it, it's a linter, it's a syntax linter, so if you've used one for anything else, it's pretty much the same. The nice thing is with the chef lint and the cook style, you actually get to run checks against the stylistic stuff that's from the chef community, which is really great on top of that. So we have linting, so our code is in a decent, passable syntax that is expected.
Semantically correct.
Semantically correct, if you will. Moon's not going to yell at me in the PR or something, or the code's not going to fail when I do a unit test. So we're good to go. So we get to the next step, which is a unit test. And a unit test is treated in Chef as the way a unit test would be in any programming language. You can think of it as a way it's a way to test each subset of, in our case, a cookbook, which are the different recipes, but even furthermore, each action taken within a recipe. And this will go through and check each thing that it's going to do to expect, action is going to be done as expected. This is a quick way, I love this. It's a quick way to catch issues before they move into lengthy integration tests, which we probably picked an example that is our longest unit test of any cookbook, because we're a little OCD about the user local monkey settings, and we'll see that here in a second. So if we look at a cookbook, so this is inside of a cookbook, we have our recipes, and then we have our spec unit tests, which are recipes in and of themselves. So for everything we've written two. I'm sure someone will be smart and be like, there's not a default test, and it's because the default literally just points to the next one. So yes, you're right, good job. So there's the monkey one, for example, there's the client install, and you can see the syntax is just called with a spec test at the end of it. And these are all the things that we kind of already talked about. So
I should mention, so there's a tool built into with the Chef DK and the Chef workstation. If you just do Chef generate recipe, it'll generate your recipe in the namespace, then also generate a just stubbed out spec test. So when we're generating these things, there's some built-in tools to save on the, like the media work.
Yeah, it'll automatically add all of your commented out headers and things within recipes and stuff like that. So very handy, and you're not creating all of these files manually. For sure, good call. So here's an example of this, this test. And here what we're doing is this is the client install. So we're going to describe the CPE monkey client install, and we're going to test on 10.13, 10.14, and then we're going to examine the logic of that. So we do some before checks, for example. So because our recipes will call the operating system for a SHA-SUM from a command line, we do a stub command, which basically is mimicking what that return would be.
Yeah, because this is all running in memory.
This is all running in memory. So as unit tests should, nothing is actually running against the machine. This is all in memory on your machine that's running kitchen.
Not kitchen, but
Chef DK. Yeah.
Chef spec. Yeah.
So then we can look at the install package, verifies that the package is installed, and then reloads the monkey components, you'll actually build in your logic here to say like, well, if everything matches, then it doesn't actually do anything, which is the beauty of Chef's idempotency, and you can see all of that logic is built into this as well. So let's watch an example. So this is chef exec rate unit, so we're just going to perform a unit test against this cookbook, and then it'll start stepping through all of the different recipes, and you can see CPE monkey client configuration, client install, and it's testing against the various operating systems as far as the logic's concerned. Yeah, and then we're going to get down to correct permissions, and we're going to not watch this because we have a fleet of developers. We actually verify all permissions within the user local monkey folder. So we ensure every time Chef runs that everything within that folder has the correct permissions. So you can see, again, this is our longest one, and it took about 8 minutes to complete. But you can also see that it touched 183 resources, which are the individual items within the recipes. Oh no, not yet, sorry. So what's really cool about this too is if you ran this and you didn't touch a resource, it would tell you that you're missing a resource. So it verifies that you have 100% coverage on your code during these unit tests. So that's awesome, 183, cool, sorry.
Yeah, and since we're testing against 2 platforms, we're testing against, well, 2 platform versions, I guess, 10.13 and 10.14. There's 366. So,
yeah,
worked out pretty well. Yeah, so I don't know if you know this, but if certain permissions in user local monkey aren't root wheel, monkey kind of doesn't work properly. And when someone does a chown who am I at user local, that'll break things. So our monkey cookbook is also probably a pretty good idea of how to write a defensive cookbook. I wouldn't necessarily, it's really specific to our environment. You probably don't have an environment where that happens often, but I just got so sick of monkey not working properly that I went nuclear. I really just kind of pulled the method of nuking from orbit. So a funny story about that guy. We've all been there. But we're going to talk about a little bit next. So we talked about unit tests, spec tests. Now we're going to talk about integration tests, which is this is the part where everyone gets really excited about it. I'm like, the integration tests are the best because I'm actually testing my code against a mocked object or whatever. So one of the things that we do is we build our own custom vagrant boxes for this. And whenever anyone goes to do this and like, wow, there's got to be like some community boxes for the Mac. As you well know, Apple has certain licensing restrictions on different things like that, but also everyone has a different MDM. And you definitely want to have your MDM in place so you can kind of test against an approximation of what your environment looks like. So I could probably give a whole talk on how to build vagrant boxes. It'd probably be attended by 2 people, maybe three, and then someone who's just in a quiet room to do their work. So what this kind of all involves is you're going to grab the macOS installer application. You're going to use AutoDMG to create a never booted OS version. This is whenever anyone says imaging is dead, I would say like, well, not for me and my workflow. But, and I kind of take it personally because I do spend a lot of time doing this, because we build a vagrant box for every single OS version that we have to support. So we have vagrant boxes going back to, I think, 10.13.2. We don't actively test against all of those because we're really lucky and our fleet, for the most part, is either on 10.14.4 or 10.14.5. So we only have 2 to actually test about all of that. But if there's anything we got to reach back in the history, we can do that. Then we use a really great tool called vFuse to take that never booted OS and convert it into a VMware box. Boot it up in VMware, and once we boot it up in VMware, then we essentially do a user-approved MDM enroll, just make sure that it's part of our MDM, and it pulls down things like the whitelisted CACs and the TCC profiles, things that we're expecting all of our endpoints to have. So then when we run an integration test on it, this is pretty much an approximation of what our end users' machines would look like if it was a never booted one in that particular regard. And then we use a little bit of fancy logic to where we put these up in S3, and there's a plugin in Vagrant that'll allow you to pull through from S3 with your AWS authentication to pull down the boxes. So granted, this is the team, so I literally probably could walk them over to Lucas. Well, not walk them, because he's in the Denver office. That'd be pretty silly. But this also ties into our CI and CD8s. We have other boxes running different kind of integration tests, and it's basically just nice. So, and also if we were to add a third person, it would really work well. And I'd be like, I already thought of that. I feel clever.
Cool. So we're going to look at Test Kitchen, and Test Kitchen by the means by which we would do these integration tests. Kitchen.ci's website, you can go visit it, it's well documented, and there's loads of support for it across multiple platforms. Not even at like so basically if you look at it from the driver level, there's loads of different driver supports. You could actually do AWS right on AWS, like you could do a token, Ubuntu or something, right? You don't even have to pull it locally. Vagrant, Docker, or whatever. And then if you look at the next level provisioner, Kitchen is supported across Puppet and Ansible at all, and then various operating systems and stuff. So just trying to like show that contextually there are other uses to this aside from macOS. It's very well supported across multiple. So we're going to look at Test Kitchen and how this breaks down. So basically in this Kitchen CI, the command kitchen test will do a lot of things in one run. So each of these being a another command that Kitchen can do. So we're going to create a VM, like Moon was saying. It's going to go pull that Vagrant if it's not already there, and then it's going to spin it up in VMware. It's going to converge the code. So all of the code that we have in our local cookbook, it's going to converge it. Chef's going to converge it over to the VM as it's running. And then it's going to use Kitchen Verify, and Kitchen Verify uses a tool called Inspec. And Inspec is a language that you can actually use to check against the node, which we're going to talk about in a second. And then Kitchen Destroy, and it'll actually tear those VMs down when you're done with them. So here's an example of an Inspec test or an integration test, one and the same in this instance, for the Monkey install. So in this example, it's very slim. So we're just saying, does user local monkey exist? Does user local monkey import exist? Is it executable? Is managed software update there? Is it executable? You can make these as as in depth, specific as you want.
Does it like ham?
Yes, yeah. Yes. Or you can do so a command, for example. You can do a shell out and verify that the version numbers and things match. There's all different ways you can kind of grok the same information, but Inspec is its own thing, and you can go like I think it's just inspec.io or something like that. Yeah. And you can see all of the different commands and things you can do. And you can see that we have we have written controls for each thing that this recipe should do. Should install monkey, should install the middleware, it should do this, should do that. So in practice, what this could look like is from your command line, you could say like kitchen list, and then these are the provisioned available Vagrant boxes that we have. So endpoints, unattended things like Zoom, Zoom displays, things like that, runners, so like maybe a machine that would exist in a CI environment, things like that. And you can actually just invoke these with kitchen test endpoint macOS 10.14.5. And what that'll do is that'll actually spin up the VM like we talked about, do a bunch of stuff, converge the code, run the inspect tests. In there you can see, through the CLI, all of the tests that are passing or not passing through this integration. And then when it's done, it'll tear it down. So I ran this on a 10.14.5, and it looks like it took 3 minutes and 31 seconds. So not bad at all. Another thing you can do is you can kind of break kitchen out even further. And say you wanted to do it more step by step. You totally could. You could manually just say kitchen create whatever. Okay, converge my code. Okay, test it, or verify it, I should say. It verifies it. Say something comes back bad. Change the code on your local machine, save it, converge again, and you can keep doing that pattern until you get it to a place that it's done like you expect it to. And then, at that point, I'd recommend going back, rewriting your other tests, making sure everything's good, and then do a full test when you're done. So this is an example that I definitely didn't record during the last session. I did it last night. I just shortened it last night. So what I'm doing here is I'm running kitchen test with a convergence of 2 endpoint macOS. So it regexes out and says any macOS endpoint you're allowed to test 2 machines at a time, and it goes through and it spins them up, logs in through SSH, converges, runs the tests, and then tears them down when they're done. This isn't great, probably a use case on the regular, because it's mashing the 2 terminal outputs together in one command line, and it's kind of hard to go through and see all of the checks. But for sake of what you would expect to see on an endpoint when you're running this, if you're running it locally, that's kind of what you would expect to see. So you can see each test has its own summary and things like that. So I think this took probably about 7 or 8 minutes to run both on my machine.
Which you should point out is a fairly new machine. So if you're running
Also
this on
if
you're running this on a MacBook Air, like a 2012 model, it may take some time.
That's fair, and it depends on how you have your defaults in your. So the kitchen YAML also allows you to have lots of defaults of the way that you want the machines to be provisioned and stuff through VMware, like cores and things like that. So then when you start looking at it, you can start thinking about how this could break out, and then how you could take all of this and bundle it up together and ship it to like a CI CD type system. So allowing things like, if you integrate with like GitHub or something and have checks that run whenever you push a branch, you could then send these commands off to your runners somewhere else, have them perform these tests for you. You're not performing it locally, and those checks, based on those checks, are either allowing the merge or blocking the merge. And again, I just want to reiterate, Mac specific example here, but there's not really any difference across platforms. You might have to deal with a little bit of provider differences or driver differences for like Windows VMs and things like that. But then there's also the ability to integrate with like AWS and stuff. So lots of options as far as the kitchen stuff goes, and there's support for it out there. Yeah. So we're back here again. You can kind of see what that looks like as far as the testing, so like the blue kind of stuff. And then what we're going to do is, once we have that, we're going to take a look at what contains within a cookbook. And we kind of already saw this with our previous atom layout. So what happens now?
Yeah, so this whole guess just stream of data and stuff like that, one of the things that really we see a large benefit from kind of following this model and version controlling all of it is we have an audit trail for everything that's on our endpoints. And we have, since adopting this approach and kind of shoehorning Lucas into making him do it, like we don't have many surprises on our endpoints, because anything that goes through this process is version controlled. The cookbooks are version controlled, the environments are version controlled. We have a whole process. We even try and do our releases only twice a week, pretending that we're an actual production instance. The engineering team at Slack is probably like 2 and 4,000 in terms of scale compared to us, but it's really just kind of the approach we're taking. We're like, hey, like everything we go through, it's version controlled, so our audits are fairly simple, because like, hey, this is all the stuff, these are all the endpoints. We can even show you the Inspec tests that really verify that. And one of the nice things about all of this is, since it's version controlled, we have all the different, sorry, jumped ahead there. There you go. Okay, so the whole thing of like doing our PRs and stuff like that, we can push out a lot of the unit tests and the integration tests to our CI and have that do that rather than spinning it up on our own machine. It's still a pretty good approach when you're writing code to actually make sure it works before shipping it off to that, but you don't have to wait that time and do those particular things. You can shove them off to different systems, and it's all tying into kind of the same framework. So there's a lot of benefit into that. One of the things that we use is we use Berkshelf to kind of manage all of our cookbook dependencies. And where this calls in place is because we do every single one of our cookbooks as an individual repo. We don't have a model repo of all of our cookbook code. And this may be just because I never let the ghost of Bash leave me, and that like every tool has a really small specific use case. Like while you could do everything with awk, and believe me, I've tried, there's also a limit to what you can do with that, and maybe a different tool like, grep would be better. I don't know, like that's probably not the best example, but since we use Berkshelf as our dependency manager, we can source from other cookbooks within our whole infrastructure as well as community cookbooks as well. And the nice thing that Berkshelf will do is that if you pull a cookbook from, say, the community, it freezes it at that version. So you say, hey, I want the Chef AWS Cookbook, which we use to kind of supply some of the S3 logic into some of our custom resources. We're going to use this in a particular cookbook. It just takes that version and freezes it. So we have that version, and nothing's going to change on that particular version that happens on our server. So if someone were to, put in a malicious bit of code in the next particular version, or try and save that version, same version number up, it's not going to do anything. It's not going to pull it down because the SHA doesn't match and it's frozen. So there's a little bit of safety kind of in pulling from a community in sense like that. I have a slide note that Berkshelf is for lovers. I don't really know why I put it there, but we can just presume that it's true. Lucas.
Cool. So what I want to do is I'm just going to run us back through kind of all of the stuff that we talked about, because I guess that's good presenting, is to tell people what you told them again. So again, we talked about workstation and all the stuff that we would do locally on a workstation. Recipes contained within cookbooks. Those cookbooks also have all of the tests. In the tests, within the tests, the controls are defined. Also locally on a workstation, you can do a lot of that testing if you want. CI/CD is definitely whole nother talk, and how you can integrate those things, but all of that stuff can exist locally on a machine. And then when you're ready to ship it, you can track that entire cookbook in version control and ship it on up to the Chef server, as well as your version control system and stuff. So you have your server with all of your different cookbooks. So then we kind of start looking at it like, okay, the cookbooks exist, they're versioned, they live on the server. Then we start integrating endpoints into it. So these endpoints are aware of, what their role and environment are, what they need to have, and then you can start expanding it out from there. Again, the beauty of Chef is the ability to support multiple operating systems. Chef itself, like Moon said, it was built for the cloud, so there's a lot of really great tooling out there. I feel like, from what I've witnessed, like the BSD support and things usually come later to the tooling, but it's still out there and it's still supported. So now you have this environment, cross-platform environment, that you have the ability to control these nodes in different environments and variables across your entire fleet, and everything's version controlled and tracked. So yeah, you get it, right? Like that all makes sense right now? Yeah, me neither. I've been really up to my eyeballs in it for 6 months now, and I feel like I'm just really truly starting to grasp it. I don't really feel like there's a fast or easy way to learn Chef, because it is a lot of work. Like, to truly understand how everything works together, it's a lot. But there are a lot of benefits that come with this way of using Chef. Version control, you're kind of using a prescribed and documented workflow that's available in the community. You know that your code is unit tested, it's been integration tested. A lot of this stands to be automated, however you choose to do that. And the logic itself isn't specific to a platform, it's just the sub-components of recipes that may be specific to a platform. So like, what now? If you're considering configuration management and that's something that you're looking to do within your organization, consider the complexity. I think our biggest hope was that we could kind of outline it and whiteboard it and show you the charts and say, like, this is kind of how it all fits together, and then you can kind of take that to make an informed decision on if that's something that would work for you. Consider the barrier of entry. It is mostly Ruby, all of the different layers that kind of go into this, but also consider, these are our opinions and our methodologies, and this is like a year and a half later for Ryan that he's got this to this point. So like, it's not going to be an overnight thing by any means. So you're kind of at the point where a road diverges in a yellow wood, and you can kind of choose your own adventure. Like, you can take the time, learn it, dig into it, and spend your time in the cave. You could go to a different methodology that may be a little farther out there in space. Either way, you might end up at the third option. So yeah, next steps. Chef has a really great website. I was pointed to this when I was first starting to get to go, and it does a really good job of illustrating a lot of these different ideas. I do feel like you probably won't get the whole picture from learn.chef.io, but it will help you learn each of the individual tools a lot. There's a Chef community Slack, just like there's a Mac admin Slack that's available, and you can log in and create an account and stuff like that. And then there's the Chef channel and the Mac admin Slack. However, I will note about the Chef channel in the Mac admin Slack. If you go to the chef channel and you go to the top and you look at the pinned posts, the last thing in there is the actual chef resources. You have your Ubers and your Facebooks and your documentation. Everything within those docs is completely not applicable here because those methodologies do not follow the prescribed chef way to build and test cookbooks. So, we in that channel, I feel like, are very much a minority. However, again, it's just kind of up to you and how you choose to do your own adventure. We're not saying that those are the right ways or the wrong ways. We're just saying that they're different ways, and each way comes with its own benefits and its own disadvantages.
Yeah, I think like one of the things that drew me to Chef in the first place, which is a long time ago, was the whole concept of like, Chef doesn't know what works for your environment because you're the one there. So you're the only one who's gonna know. Is like, hey, am I gonna do this really complex and like add all these additional layers? Is this kind of expected, or is it just no one really matters about the complexity of it, they just matter of whether or not you're getting it done? And I think one of the beauties of like having a couple different approaches as to how you can apply this is you can also just kind of pick and choose from what kind of does and make it kind of your own, just like you would your GarageBand, whatever. It's not going to be.
Cool. Our slides will be posted. We'll have a links to a lot of the different things that we talked about on there. So you can always find us on Slack for obvious reasons, or on Twitter. Just find us on Slack, Mac Admins or the Chef one. Cool. So yeah, we're gonna just take the rest of the time and open it up if you guys have any questions or anything. Or we're gonna run the box up coming to you.
So early on, like 5 or 6 slides in, it looked like you were using Chef to do configuration profiles.
Yep.
But that command is going away. So is Chef building a profile on demand, or is it just using like defaults right somewhere, or going somewhere else in the preferences hierarchy?
Yeah, you are correct. That will go away. Yes, totally.
But all the profiles resource, which I believe was maybe written by Mike. It might have been Nate's fault. I don't know. See, Nate, this person, he wrote the very tool that we use. But as best as I can understand, it's really just a wrapper around an execute, right?
That's what everything in Chef is.
Yeah.
Everything in Chef is a wrapper around a command line tool,
Yeah. So I'm going to be really sad when that goes away in 10.15 because I really like it. It's pretty, and I really like using it. We're going to have to find a different way. But one of the just backing up, when I first started being a Mac admin, I was an Xan administrator. So clearly something had to change because I'm here now. But the technology is always going to change. It's always going to keep us employed because it's always changing. It really stinks because it would be really great to just write something once and then never have to deal with it again. There's a potential that like you could abstract the logic it further of like figuring out a way to talk to your MDM to deploy a specific profile based on the configuration. That's probably the avenue in which we would start getting a little fancier. Whether or not that's going to be a good idea or a bad idea, it'll probably start off as a bad idea and then we'll start using it completely and then convince ourselves that's a good idea.
And to be clear, profiles are not necessarily going away in 10.15. It's just sometime.
Yes. Sometime. Yes. The ability to generate them systematically will cease in the future versions, TBD.
Yeah.
So, cool. Does anybody else have any questions? All right, right here, this guy, front row.
Yeah, so you guys were at Berkshelf, that's pretty cool. You guys were at ChefConf, I saw you there, both personally. They were making a lot of noise about policy files. Are you guys thinking about moving in that direction, or, okay.
So policy files, so there's a really big approach by Chef in the way that they're doing Chef Server and what they're calling now Chef Infra Server and their different products. So they're proposing an idea that they call it serverless, and then a component of that would be policy files. There's some things you can do with policy files that are really great. When I first thought of them, I was like, well, this is basically treating all of your machines as pets rather than as cattle, which obligatory. If you're talking anything DevOps, you have to use that phrase. So I'm glad we got that out. So mark that down on your bingo scorecard. But there's actually a bunch of different things in policy files that aren't necessarily in that particular approach. I've never used them. I've always kind of prescribed to using the environments and different things like that. To the best of my knowledge that I know about policy files, you can't do cookbook version pinning. You can just say, hey, these are the cookbooks that need to be applied to a specific machine. So that loses some flexibility for us, because one of the things we like to do is anything that's in master is up on the Chef server. So even if it's version 6 and we're pinning everyone to version 4 of the monkey, stuff like that. And the nice thing is like with the version pinning, it also gives us the ability to do a rollback if we just miss something completely, which we've had to do like 2 times maybe.
Yeah,
it was really nice because like, oh hey, look at that, the mistake never happened. Unfortunately, it did, but yeah. So I'm interested to see where that goes, because it seems they're just kind of starting that particular approach, but they really haven't fully formed it. But I think you could say that for a lot about the changes that are coming to Chef. It's like it's much similar to the idea of like setting profiles in the command line. It's going away sometime in the future. I think there's changes to be coming to Chef and as a whole sometime in the future would probably be the best way to put it.
Yeah, for sure.
This is unrelated, and I get to do that thing you do at conferences, right? Or this is more of a comment than a question. But with your rake linting, do you consider throwing that into like a Git hook or something like that? Like, I don't know if you guys saw Elliot's pre-commit session earlier in this conference or not.
Oh yeah, that has been my bread and butter for at least like 6 years, and I think I finally broke down and yelled at you to do that on every single one of the cookbooks.
It didn't take very long.
Yeah. Just because there was a point at which, so I do that basically as part of my Git commit. So it runs through the linting. Sometimes I'll run through the unit tests if I want to sit there. Unfortunately for the monkey cookbook, since we do it so defensively, every time I do a Git commit, that's 8 minutes I'll never get back. But the nice thing I know is like when I'm committing the code, I know that the code's linted and it at least passed the unit tests, and you can go like that. Once we get our CI kind of more fully in spec, I think we're going to just scale it down to just doing the linting, because if the code doesn't lint, it's never going to run. So that kind of approach there. But yeah, I think the nice thing is because all this is code, you can think of so many clever things to help speed up time and do things like that. Like for instance, I'm a really big fan of using like Keyboard Maestro shortcuts, and I have a whole fancy workflow to do like my tagging, where it'll create a Git tag and also bump the version number in the metadata file, and then make sure that those are in sync, and send a Slack post and different things like that. So yeah, there's no shortage of things that you could use to make your life easier or more complex, I guess is the way to put it.
Cool. All right. If there's nobody else, we'll be around for a little while at least before we hit the road. Thanks for coming, and I know it's the last day, and this is a very easy to digest topic, so we really appreciate it.
Yeah, thank you very much.